Hey, here's me. There's you. Look at this. Coming in for a landing. There's my feet. Why did I do that? So I never read Rate Your Professor. You know, if you were LeBron James, would you waste your time reading what the newspaper says about you? Probably not. And I don't read that. So apparently somebody told me on Rate Your Professor, it says, he walks on the furniture. There's the furniture I just walked across. Just proving to you that it can actually happen. How about that? All right. That's not, of course, what this is about. This is about our lab today. Remember, I have hard copies of these. But you have the one online, the digital copy. And what I want you to do is this. Look at the part that has to do with the rotation of the Earth. All right? Take my glasses off. Put my sunglasses on. Yeah, there we go. Better, huh? All right. So here's an Earth, or globe. It's got a little problem right there. Maybe got hit by a meteor or something. So the Earth does this. The Earth rotates one of these four ways. West to east, east to west, north to south, south to north. Come on, let's eliminate two of those. Which two can we eliminate? Obviously, we're not going north to south or south to north. That happens. That also happened. And class is canceled permanently. So that only leaves us with west to east or east to west. And think about it. Right now in the classroom, it is, the clock's not working. What's it say on the computer? 11:15. So it's 11:15 a.m., not p.m. And I am on the west coast of North America. Do you know what time it is on the East Coast? Like, for example, in New York, if it's 11:15 a.m. on the West Coast, what time would it be on the East Coast? That would be, yes, they're 3 hours in front of us. So it would be 2:15 p.m. Okay? The time zones on this planet are actually stationary because human beings made them up. But the planet is rotating. That's for real. And if we on the West Coast are occupying, here's the West Coast right here. There we go, California. If we are occupying the 11:15 a.m. time zone, and for example, New York, which is right there, okay, New York, hope I pointed at the right one, but you know where it's at, the East Coast, is occupying the 2:15 p.m. time zone. In order for it ever to be 2:15 p.m. in Southern California or on the West Coast of the United States, we have to go to where New York is because the time zones are stationary. We rotate into them. And if it's 11:15 a.m. and we need to get to 2:15 p.m., we're on the West Coast and we are going to the East Coast. That means we are rotating from west to east. Yes, indeed. There we go. That's the way we rotate. Very good. West to east. So the Earth is always rotating west to east. And it doesn't matter whether you're that big globe, whether you are this smaller globe, or whether you're the little guy. Look at the little guy. There he is. Little guy. Little guy also rotates like this, west to east. Always west to east. We don't want that to happen to the Earth, though. Okay? But watch this magic. If we are rotating west to east, and indeed we are, okay, here we are rotating west to east. If you were directly above the Earth, above the North Pole, and you were looking at the way the Earth rotates, and you were comparing this to a clock, which way do we rotate from the North Pole? Clockwise or counterclockwise? Okay, we're always rotating west to east, but from the North Pole, clockwise or counterclockwise? Now watch this magic. From the South Pole, look what happens. Well, you have to be able to see it. From the South Pole, now which way are we rotating? How about that? So from a Northern Hemisphere perspective, we are rotating one particular way. From a Southern Hemisphere, a different way. Always west to east. Always. Doesn't matter where you are. But whether you are rotating clockwise or counterclockwise depends on which hemisphere you are in. All right? Be able to answer that stuff. Good.